Krish, you were saying something.
No, sir, Adesh was telling something.
So the chapter is over.
Chapter is not over. None of the chapter is over, are they? Don't make such a claim.
No, so the theory, I meant the theory.
There is nothing as such called theory in simple harmonic motion. They were all equations. And the physics which you are learning over here, Adesh, did I
Yes, sir.
ever make you write notes?
No, sir, I'm writing it on my own.
Oh, we have been writing only equations. We have been learning physics by examples. Correct, yeah?
Yes, sir.
It has always been the case with me. With problems, we are to unfold theory. And that is
Yes, sir.
what I do. Simple harmonic motion, when you're talking of, on theoretical front, you have only the graph, variation of potential energy or kinetic energy with x and time. X I did and time I have left for you to show me. You were not present that day. I have asked Krish, I think you will bear me out on this. I asked you for potential versus time plot, getting you potential versus x plot for simple harmonic motion, right?
No, sir, you don't ask us to plot for time.
Okay, time I have not asked for. In that case, I'm asking you to plot for time. X did we do? U versus X did we plot?
Yeah. Yes, sir, we plotted for U
Okay.
versus
So
X.
I extended to time, but I presume I got you the frequency and I made you right. U is nothing but function of sine omega t. Correct
Ah,
me if I'm wrong
sir,
there.
yeah, yes, sir. You wrote all of that. So frequency, you wrote for all of both of them.
Yeah, but did plot for the same, right? That is what I'm
Yes, sir.
asking. That
We did not
I
plot.
may have missed on asking you. Fine, I concede there. So I am to make it clear. You are to plot U versus time and show me. Could you do it right away? Not much being done there. I don't think nothing is left out there. Could you get it right away? U versus time. Because you are aware of sine square omega t function, right? Yeah. All of us are
Yeah.
aware of sine square omega t function, correct? Let
Yes,
me
sir.
bring it for the advantage of Adesh as he was absent here. So U is equal to A, we wrote that day. We wrote potential energy as half m omega squared, and kinetic was written as a square minus x square and potential only x square, right? This is what we wrote the other day. Check once. Half m omega square x square, right?
Yeah.
And kinetic in accordance was marked as, kinetic energy was marked as half m omega square a square minus x square, right?
Yes, sir.
And then I got you aware of what is x there. X is sine of the angle omega t, cos or whatever. Phi depends on initial state. You are aware of it, correct? Yeah. Phi
Yeah.
is
Yes,
initial
sir.
state.
Yes, sir. That I'm aware of. Yeah.
Yeah. So phi is subject to our understanding. Let me take the simplest of them all. A sine of the angle omega t. Thereby I am suggestive of phi being 0 at t equal to 0, correct?
Yes, sir.
That means particle is at mean position at t equal to 0 and moving
Yes.
towards the positive side of x-axis, right? Yeah.
Yes.
Okay, so U is what to us? Half m omega square a square sine square omega t, which is then indicative of U being a constant into sine square omega t. This can be plotted very well on U versus time. What we'll say? We'll say it is repeating itself after pi by omega. Agreed?
Yes, sir.
So we can show the sine function and make the repetition apparent. It repeats after pi by omega. This is how you will vary with time. Correct?
Yes.
Yes, sir.
We find, yeah, yes, Krish, you were asking something, were you?
No, sir. For KE, it'll be cos curve with pi by omega, no, sir?
Yes, it'll be fast. So the start here, time period will remain same as you know. Nature is slightly to be tweaked. Correct?
Yes, sir. Sir, are these curves
Okay.
continuable or differentiable? So can
They
you
are
explain?
continuous. Yes. Mathematics is asking for shall I show it with a sharp distinction or should the transition be smooth? This is a very good question which Trish has posed over here. Can I show it with sharp distinction or shall it be a smooth transition? You can prove to yourself that it is not only continuous, of course it is continuous, that goes without saying. We are checking on differentiability. It is also differentiable at these points. It is also differentiable at these points. And that you can do by differentiating it and checking for left of the point and right of the point. Correct, Rish?
Yeah, yes, sir.
Whatever you will get for x minus, you will get the same for x plus when you apply limits. And that's the only way mathematically by which we can have a substantiation on differentiability. Correct?
Yes, sir.
So we can prove, and this makes a very good mathematical question. We can prove that it is differentiable at these points. Got it, Krish?
Yes, sir.
So the transition should always be smooth. If it is not, it's incorrect representation. Fine, yeah?
Yes, sir.
Okay, Krish, is it fine?
Yes, sir. Yes, sir.
Okay, good enough. Let's further then with questions. Let us hit the ground running right down. Given a rod of mass and length L, given a rod of mass and length L, is placed on two wheels which are fixed, is placed on two wheels which are fixed and rotating as shown in the figure. Two wheels, they being fixed and rotating as shown in the figure. Find equation of motion exhibited by rod. Find equation of motion exhibited by rod, it being equipoised initially. So it is poised evenly initially. Is it okay to all of you?
Yes, sir.
By this statement, what I mean, center is located symmetric to system, correct?
Yes, sir.
Center of rod is located symmetric to system being equipoised, but the wheels are rotating there. The wheels or this, they are rotating with angular speed omega. Both the wheels and the sense being shown over here, correct?
Yes, sir.
Sense of rotation being shown over here, and you are gently placing rod on it, and you are keeping umpteen care of it being equipoised when you place it. Fine, yeah.
So equipoise means symmetrical. Yes,
Symmetric.
sir.
Center of mass is midway. If L is the length, then L by 2 is where lies center of mass. Correct, yeah?
Yes, sir. Yes, sir.
So L by 2 evenly placed, center of mass is evenly placed in the system representation. That is what I mean by equipoise, right? Fine, Krish?
Yes, sir. Yes, sir.
And it is more than what meets with this word, because I have to also take it in spirit. Not only in word, but spirit. By equipoise, I also do mean that system has got equal inclination to move in any direction. System
Okay.
has got equal inclination to move in any direction. By that, what I'm suggestive of is system is in equilibrium. What equilibrium? I'll come to it later. But as of now, system is in equilibrium. Is it okay?
Yeah.
Yes,
Yeah.
sir.
System is evenly poised. Yes, it is evenly poised, but only for the state shown. When you are placing it, keeping symmetricity very much in adherence. So symmetricity in adherence, you place it over here, and then I am in ask. Tell me, as for you, will friction act at point of contact? If there is friction between disc and rod, then what is your take on friction? Will friction act at point of contact? Yes or no? Will friction act at this point? Will friction
Yes, sir.
act at this point?
Yes, sir.
What comes to you?
Yes.
Think about it. Think about it, dear.
Yes.
Tell me, will it act? There is friction, there is mu. So don't be cagey about there being mu or not. There is mu. And that mu may not be sufficient to arrest slipping. It is not possible to arrest slipping, but that'll come later. For now, I'm just an ask on. As this was trying to spin, and you place rod on it, correct?
Yes, sir.
This
Yes, sir.
rod trying to spin about the pivot, respective pivot, and you have placed rod on it. Say me yes or no, all of you.
Yes,
Yes,
sir.
sir.
So when we place rod on it, aren't we an hindrance in free rotation of disc?
Yeah.
Aren't we applying a force, a hindrance force or a torque, whatever? Aren't we trying to change its state of rotation? Yes or no?
Yes, sir.
Yes.
So we will try to change it by applying force. Therefore, rod will apply force on this. In which direction? This direction, agreed? Think about it, think about it. Think, take with pinch of salt every statement that I'm into making. I may make you fall for the bait. Please be careful. And I'm making the disclaimer right at the top of discussion. So please be very careful in picking on what I'm trying to suggest. Ring is rotating, disc is rotating, pulley is rotating. I place rod on it. Thereby, I'm trying to tweak situation. If I'm trying to, then I will actualize it by force. So force which disc will be subjected to owing to rod being present is to the left. Agreed?
So, but then there's the other disc rotating in opposite direction, no, sir?
Yes, correct. I'm asking for this disc at first.
Okay.
At
Okay,
this
then
point
okay,
in
yeah.
time, I'm related to this. I'm just with blinkers on this disc. On this
Yeah.
disc, force will not depend on what the other is to apply. That is for sure, Krish. Correct? Yeah.
Just no, sir, I thought for the entire body you're telling, just like
No,
that.
no, only for
Yeah.
this. Can we limit our understanding only to this disc now? And then
Yes.
C4 that on this disc, rod is applying force in which direction? Do you subscribe to this direction? Agreed?
Yes, sir.
Okay.
Yes, sir.
So what will this do? This will in turn apply force on rod. Correct? Yeah.
Yeah, yes, sir.
Yes,
This
sir.
is action. Then this will be reaction. Say me yes or no?
Yeah. Yes, sir.
Yes.
Yeah.
We write it as FK1. Any problem?
No, sir.
FK1. Okay, kinetic. Or if you do have problem with will it slip or not, then I write FFR. Just to free myself of the argument, whether it's FS or FK, I choose to write FFR, force of friction. Convincing?
Yes,
Yes,
sir.
sir.
Okay.
Yeah.
Now I shift my attention to the other spinning disc, which Krish was indicative of. Krish, this one is rotating in anti-clockwise sense, correct?
Yeah.
And you place rod on it. Find ya. So if you place rod
Yeah.
on it, what will the rod try to do? Reduce omega, correct?
Yes, sir.
Thereby applying force in which direction? This direction. Correct, yeah. Over here in this direction, correct? Force will be
Yes, sir.
applied at point of contact only, right? Yeah. And in which
Yeah.
direction? This direction, right? Yeah.
Yeah. Yes, sir.
Yes, sir.
What about force on rod due to this disc?
So in the
Which
other
direction?
direction.
Opposite.
Opposite to
Opposite.
this. So this is what we write. We write over here FK2, or if you do have reservation, FFR2. Okay?
Yes, sir.
Yes, sir.
Now, with the two forces being applicable, if the rod is not to move, if the rod is not to move, and the rod is ordained to slip, tell me yes or no. If the
Yeah.
rod is not to move,
Yeah.
if I'm arresting motion of rod, then rod is ordained to slip on the disc. Agreed?
Yes,
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 sir.
sir.
So in that case, which force of friction will act? Certainly Fk, right, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. And Fk depends on normal, right, dear?
Yes, sir.
Yes,
Yes,
sir.
sir.
It depends on normal. Say me yes or no.
Yes,
Sir.
sir.
Yes, sir.
And normal acting at point of contact. I'm marking overhead N1 and marking overhead N2. Owing to symmetry or something. Owing to symmetry, can we say, please think over it. Contemplate tea leaves because there are many questions into coming. So please be in contemplating tea leaves mode. What all are into coming? Please try gauge on those. N1, N2 is what I'm writing for them. Anyone having any reservation, any qualm?
No, sir.
qualm?
No, sir.
No, sir.
Qualms? Okay.
Yes, sir.
Can I say N1 is equal to N2 owing to symmetry of state?
Yes, sir.
Yes,
I
sir.
say,
Yeah.
can I make that claim that N1 will be equal to N2? Yes
The
or no?
mass and radius of both the wheels are same.
Yes, yes. Oh, exactly. They are in toto the same, splitting image. Is it clear?
Yes, yes, sir.
Yes, sir.
The normal will be same.
They are splitting image. What is your take on normal?
The equal.
Same and one
Yeah,
equal to
equal.
N2, yes or no?
Yes,
Yes,
sir.
sir.
Okay. So if N1 is equal to N2, Fk1 will be equal to Fk2, right here?
Yes, sir.
Yes, sir.
Okay. And if Fk1 is equal to Fk2, then the rod is not to move on its own, correct?
Yes, sir.
Yes, sir.
Okay. So in order to make this rod move, I'll have to nudge it. I have to shove it, correct?
Yes, sir.
Yeah.
Okay, let us do the required. I shift it to the right. Got it? What did I do? I am shifting it to the right. I shift the rod slightly, very slightly to the right. If I do so, then center of rod will move to right by some amount, let's say X. Got it, yeah?
Yes, sir.
Yes, sir.
Okay. Now, as it shifts and shifts to right by X, what will happen at different point? You are to tell me. First things first. Here, will it slip or not? If you are moving it forward, and moving forward by whatever quantum you are, can you be wary of? Can you discount that there will be a slipping over here? Tell me, yes or no? Can you look the other way? Saying that there is no slipping over here, or you'll be mindful of the slip over here? Tell me, dear. This you are
Sir, I don't.
maintaining. This omega you are maintaining. So this omega has got nothing to do with the position of rod. Are you getting it?
So can you explain from the part of nudging once more?
You are shoving it to the right, pushing it to the right. Is it okay?
Yes, sir.
So as you have pushed it to the right, yeah, will you not brush all the more this disc?
Yes, sir. Yeah.
Sir, but
Not moving,
you can
when
discount
you are
on
not
slipping.
moving rod, even then you are brushing it. You are rubbing it wrong ways. Correct? Yes, yes or no?
Yes, sir.
Yes, sir.
Now it will be all the more compounded, right? Yeah. Now it will be
Yes,
all
sir.
the more compounded. You are redoubling it. How you are redoubling it? By making it move to the right. Agreed?
Yes, sir.
Yes, sir.
Yes.
So here this is getting rubbed and getting rubbed all the more. Friction is to act again. Which force of friction? Fk. Agreed?
Yes,
Yes,
sir.
sir.
Okay. So Fk will act, and Fk depends on mu and normal. Mu is constant, of course. So Fk is to depend only on normal in this case. Tell me, will you now be of the same opinion, or you make a departure? The opinion that you began with a premise that N1 is equal to N2. You began with a premise that N1 is equal to N2. But that was the case when it was equipoised. You nudged it, you disturbed it, and as you have disturbed, center of mass shifts to the right, force of friction is still acting in this direction, so Fk2 is to act in this direction. What about N2? Is N2 same as N1 even now, or is different? You'll have to justify whatever you are into making. Whatever you are into making, you'll have to justify. So first I'll
Sir, I
ask for you.
guess.
Will
Sir, I
N2
guess
be equal
N2.
to N1, Krish?
Sir, I guess N2 will be equal to N1 because there's no change in horizontal forces, no, sir.
Okay. Horizontal or vertical?
No, vertical. Sorry, vertical. Yeah. Sorry.
Okay, fine. I'll take that point. Yes, Vedant.
So I'm with Krish only. Vertical forces are not changing.
Okay, Adesh.
Yes, so 1 minute. Sir, I'm with Krish only. Yeah, same. Krish and
Okay,
Ved.
Piyush. Piyush.
Yes, N1 will be equal to N2. It will
Okay,
be
fine.
same.
Now, N1 will be equal to N2. Fine. Okay. So all of you were in agreement with vertical force or forces are not to change, right? Yeah.
Yes, sir.
Yes.
I don't have any problem with vertical forces are not to change. I don't have any problem with vertical forces are not to change. My question was on a force. My question was not on total force, net force. It goes without saying that net force should remain the same. So N1 plus N2 will be equal to mg. I am not contesting that statement. Getting it here?
Yes,
Yes.
sir.
Okay. My ask was on will N1 be equal to N2? And they are different scenarios. Getting it? Getting
Yes,
it
sir.
or not? There are
Yes.
two different situations. There are two different situations. Situation number one, you say net force in the vertical direction are to remain the same. They will get us an eventual answer 0. I am good with it. I am good with it. I am asking for the intermediate change. Is it possible for N1 to change? Is it possible for N2 to change? So I am very specific. Getting it?
Yes,
Okay,
sir.
yes, sir.
Yes, sir.
Now, if you may re-evaluate and let me know on them. Is it possible for N1 to change? Is it possible for N2 to change? Because we know net is not to change, of course. So if you are still with your statement being N1 equal to N2, if you are still up with your statement being N1 equal to N2, I'll ask you to place yourself at center of mass of rod. Okay? I'll ask yourself to place at center of mass of rod. Place yourself at center of mass of rod. Got it, yeah?
Yes, sir.
Yes,
Yes,
sir.
sir.
And you are known to that this length will be L by 2 plus X. And this will be L by 2 minus X. Agreed?
Yes, sir.
Yes, sir.
Yes, sir.
If N1 is equal to N2, if N1 is equal to N2, then torque due to N2 will be different from torque due to N1.
Yes, sir.
Yes, sir.
N1 is equal to N2. If N1 is equal to N2, then this rod should rotate in clockwise sense.
Yes, sir. Yeah.
Yeah.
N1 is equal to N2, then this rod as seen by you and you are positioned at center of mass. You are stay put at center of mass. Is it okay?
Sir.
Yes,
So
sir.
mg will not produce any torque about the point that you are stay put, correct?
Yes, sir.
Yes, sir.
But normal will, the two normals are, now you are saying N1 is equal to N2, I go by it. But N1 is further than what N2 is from center of mass, from your position, correct here?
Yes, sir.
So N1, which is equal to N according to you, multiplied with this distance, will produce more torque than N2, which again is N according to us, multiplied with this length, correct?
Yes, sir.
Yeah.
So under this scenario, the rod should start or should be seen rotating about your position. Same yes or no?
Yes, sir.
Yeah.
So, what we understand of this presentation, this is what is I you to do. What we understand of this presentation, dear?
The
We
N1 is
understand
not equal to.
this presentation that N1 will be equal to N2 only for one position.
Yes, sir.
N1
Yeah.
will be equal to N2 only for one position, and that being what is known to all of you, correct?
Yes,
Yes,
sir.
sir.
If you displace it to right or left, N1 and N2 are to change, and they are changing. Now, equation of motion. Help me write equation of motion, all of you.
So one
Fk1
question.
here, Fk2 here. Is it okay?
So one.
Yes.
Fk2.
So one question. How is this related to SHM, sir?
Let us see. Let us see, Krish. Will it on a question? Let us see. Find out.
Yes, sir. Because there's no.
Let's see. Everything will be mathematically for you to take a call. I'm not to appropriate words to you. Is it okay?
Yes, sir. Yes, sir.
Okay. So let us write equation. Let us write our equation. I think you will approve of this equation. Fk1 minus Fk2 is equal to mass into acceleration. Anyone having any problem with this?
No, sir.
Fk1
No,
to
sir.
the right, Fk2 to the left, and I'm assuming it to move to right, correct? Yeah.
Yes, sir.
Yes,
So
sir.
Fk1 minus Fk2 is equal to m into a, right?
Yes, sir.
And Fk is nothing but mu into normal, that also known to all of us. So N1 minus N2 is equal to m into a, agreed all of you?
Yes, sir.
Yes, sir.
Now, this is what we have got, and also we know that the rod is in equilibrium. This is not in translational equilibrium, but certainly it is in rotational equilibrium because rod is not to rotate. Under that circumstances of study, N1 into L by 2 plus X minus N2 into L by 2 minus X should be equated to 0. Agreement?
Yes, sir.
Yeah,
This
sir.
should actually be equated to I into alpha, and alpha over here is 0, right? Yeah.
Yes, sir.
What we get
Yes,
to
sir.
see here, we get to see from here a relation N1 minus N2 into L by 2 plus n1 plus n2, right here, into x is equal to 0. Labor me out on this. Is it fine with all of you?
Yes, sir. Yes, sir.
Segregated the terms. Okay. So n1
Yes, sir.
into x is equal to mg. And all of you are aware of that n1 plus n2 is nothing but mg, right? Right.
So,
Yes, sir.
yes, sir.
And 1 plus n2, if you take the vertical balance state, n1, n2 on rod, and mg on rod downwards, right? Yeah.
Yes,
Yes,
Yeah.
sir.
sir.
1 plus n2 is equal to how much? mg?
Yes, sir.
Yeah.
So, n1 minus n2 into L by 2 plus mgx is equal to 0. Agree?
Yeah. Sir, and n1 minus n2 is equal to this one, ma by mu.
So, what shall we replace this by? Correct?
Yeah. Yeah.
So,
Yes, sir.
mu as it is, and n1 plus n2 replaced by minus
Yeah.
of
It is.
mx into 2 by L, right?
Yes,
Take it
sir.
Yes, sir.
here.
And
Minus
it is
of
SHM, sir.
mgs into 2 by L equal to, now tell me, Krish, is it not
Sir, it is.
supportive of SHM theory?
Yes, sir. Yes, sir, it is.
Acceleration is proportional to displacement and opposite in nature, right? Yeah.
Yes, sir.
So the rod will execute simple harmonic motion with an omega 2 mu g by L under root. With an omega 2 mu g by L under root. Got it, all of you?
Yes,
Yes,
sir.
sir.
Then you can comprehend it as you can comprehend it now, because Krish did ask me a question which was difficult to comprehend. So I'm trying to decipher it for him. Look at this, Krish. As you are moving, N1 is changing and N2 is also changing. Correct, Krish?
Yes, sir.
So as the rod moves to right, you know what will happen? As the rod moves to right, let me ask you one. As the rod moves to right, N1 and N2 are changing. Which will increase and which is to decrease? As the rod is moving to right, which one should increase to maintain the equilibrium? Which equilibrium? Rotational equilibrium. Distance is decreasing, right?
So
From this one.
Sir,
So
yeah,
N2 should
so
increase,
N2.
correct, Krish?
N2
N2
should
is,
increase.
yes,
Will
sir.
increase, FK2 will increase, correct, Krish?
Yeah, yes, sir.
So FK2 will increase, that means the rod will then have an inclination to move leftwards, correct?
Yes, sir.
Yes,
So
sir.
more it is going near to the right one, more inclined it will be to move to the left
Yep.
side, correct?
Okay. Yes,
Yes,
sir.
sir.
Yes, sir. Yeah.
With force of friction is itself changing the value with x, thereby SHM is maintained. Got it,
So,
yeah?
so it'll move right, left, like that.
Yes, yes, it'll keep on moving left and right. Okay?
Yes, sir.
Now,
Yes.
very important point. I'm slightly into going beyond what Ayurveda has suggested, and I ask you, if rotation were to be seen this way, then what will be the case?
So then FK2 will change its direction.
Now, let us see, think about it, give a thought, okay? Spare a thought to it. Think what will happen if rotation were to change their sense. Both the rotation changing their sense. Is it okay?
Yes, sir.
Think about it. Think
Yes.
about it back your place. So far as this question is concerned, it stands solved. Correct? Yeah.
Sir.
Yes,
Yes,
sir.
sir.
Okay. Fine. Write down. For a spring sphere system, for a spring sphere system, as shown in the figure, for a spring sphere system, as shown in the figure, find angular frequency, find angular frequency given there is no slipping, given there is no slipping at the point of contact, given there is no slipping at the point of contact. So this is fair to us. This is the spring of certain spring constant. Sphere is free to roll without slipping on horizontal ground. Mass m, radius r. And please be mindful of the fact that we do consider simple harmonic motion only for very small values of displacement, correct?
Yes, sir.
Which
Yes,
qualifies
Yes,
sin
sir.
x being greater than x. You know that very well, isn't it?
Yes.
yes, sir.
So, that being there, we are to assume it is very small. By that, what I mean, you are not to change orientation of spring. If it is horizontal, the horizontal sense is to be retained. Is it okay?
Yes, sir.
Yes, sir.
Logical, I do understand. I that it will tilt. Of course, it will sag. It will have to sag a little bit. Why? Because this point is moving down. But that we are to discount. Correct? Yeah.
Yes, sir.
Okay. So we are assuming it to be maintaining its erect state. If it is in erect state parallel to horizontal ground, you are to find omega for this system. What will be omega for the system? Initially, spring is in its natural length. As in general, you do have, in more cases than one, initial state will be stationary. You have to move it. So you shove it a bit, and when you do so, what will happen? It will move to right. Let's say I'm shoving it to right. So this disc is now moving to right, rotating to right. Got it?
Yes, sir.
Yes, sir.
There is no slipping at point of contact. There is no slipping at point of contact. Here, there is no slipping. Okay. But I need to get from all of you, what I need to get from all of you is free body diagram. All of you, please label me out on that. Please get
The first
me
one,
free body diagram. When you have
sir,
displaced it to the right, you can take your displaced it to the right. So free body diagram in that case. How many forces will
MG,
act on the spring? Tell me, dear.
the three forces, sir, in MG, normal, and KX to the left. Yeah,
Okay.
KX to the left.
So kx to the left I take. I'm showing it this way. Normal and mg I don't have much to do with.
Mm. Yes,
If
sir.
kx is to act, if kx is to act, then how will you arrest slipping? If only kx is to act, will you be able to arrest slipping at point of contact?
No, sir.
If you apply force here on a sphere, this basically is a sphere to you, and you're applying force this way, right? Whatever be the force, kx over here, you're applying force this way. So can this sphere roll without slipping?
No, sir, there should be friction.
There should be friction. So there must be friction force acting at point of contact. Now on
Yeah.
direction of force of friction, if you can enlighten me. In which direction will be force of friction? All of you think about it. Think about it, yeah. In which direction force of friction should act?
Sir,
And we
to
have had
the right.
discussion on it.
To the
We have
right.
had detailed discussion, correct, yeah? Were it
The
Yes,
hoop, you
sir.
would have said no force of friction will act, yes or no?
Sir, to
yes,
the
Were it
right.
hoop, were it hoop, you would have said no force of friction will act, correct?
Yes, sir. But
Okay, it is not a hoop, it's a solid sphere, let us say, or a sphere as we call. So what did you say, Krish? Left or right?
Sir, to the right.
Okay. Kadesh, think about it.
yes, sir.
Yes, sir means which direction? Decipher your yes, dear. Define your yes, dear. Yes means what? Which direction? What's
So
the
to the
friction?
right.
To right.
To the right.
To the right. Okay. Yes, Vedant.
Sir, right, forward. Yeah.
I think all of you are aware of. Just I am changing slightly for you to make a better analysis of the same. If I apply force in this direction, correct? Yeah. If
Yes,
I
sir.
apply this direction, and you are at a distance 2 by 5 r from center of mass, right? If you
Yes,
apply
sir.
Yes,
here,
sir.
no friction. If you apply here, then there will be no friction, no reaction, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
If you are above, and if you are below, then what happens? Tell me. If you are below this point, force of friction act in which direction? These points you should not lose on there. If you're losing on these points, entire purpose is getting torpedoed. Please don't do that. I told you for this point, and then I told you what will happen if you are
Sir, it
below
acts in the forward
and
direction.
what outcome of it. Come on, tell me now. If you are below, in which direction friction acts? Think about it. I'm not insinuating what you
To the
are.
left. To the
I'm not
left.
against it. Yeah, which direction? If you are below, how will it move? And in which direction friction will act? If you are below, then it acts in the backward direction. Correct? Yeah.
Yes, sir.
And if you are above, then it acts in which direction?
Right.
Forward
Forward.
direction. Remember it.
Yes,
Yes,
sir.
sir.
Yes, sir.
How did we get that? Fs is equal to m into a. Remember or not?
Yes,
Yes,
sir.
sir.
And then
Yeah.
Fs into r. Let's say I am at what point? I am over here. Fs into r is equal to 2 by 5 mr square into alpha, right? Yeah.
Yeah, yes, sir.
Yes, sir.
If I am at r, so Fs into r is equal to 2. And then I ask you, what about the value of r alpha? 5 Fs by 2m you got, correct?
Yes,
Yes,
And
sir.
what
sir.
you said? You said r alpha is greater than a, correct? Yeah.
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Yeah.
If r alpha is greater than a, friction force will act in which direction? In
Forward.
the forward direction. Remember
Forward.
this. Above this point, same as that of force. Below, opposite. Got it?
Yes, sir.
Yes, sir.
Here, now tell me. You are above or below?
Sir, above.
So
Above.
in which direction it should act?
So then forward.
Forward means
Forward.
what are they? Left or right?
The
The same
left.
direction.
It will
The
act
left.
in
Right.
the same direction as that of force. You can zero it down to that. Same direction as that of
Force.
Force. Oh,
Force.
okay.
force. So force is in
Left.
which direction? Left.
Left.
For
Left.
force of friction act in which direction?
Left.
Left.
Right.
Yes,
Got it
sir.
or not?
Yes, sir. Yes, sir.
Yes, sir.
In that case, if this is force of friction, as you have moved it to right and left. When you move it to right and leave, then it is being pulled. And as this being pulled, this point force of friction will act and will act in which direction? This direction. Got it, yeah?
Yes, sir.
Yes, sir.
Yes.
Now, if we are at center to right, rotational mechanics equation, then we get kx into r, right?
Yes, sir.
Kx into r minus fs into r, kx into r minus fs into r is equal to I naught into alpha. Right?
Yes,
Yes,
sir.
sir.
Okay, this is one equation. This is equation pertaining to rotational aspect of body. Now, can you help me equation pertaining to translational aspect? What will happen? Kx to this direction, fs to this direction, correct? Yeah.
Yes, sir.
Yes,
So
sir.
what
Yes, sir.
Fs plus kx can be
Yes,
Yes,
sir.
sir.
Fs, kx, and what is happening over here? X is increasing or decreasing when it is coming to this side. When it is coming to left, mind you have taken extension as x. That means this is your positive x, correct?
Yes, sir. Decreasing.
Yes, sir.
So what shall we write? Is equal to m d square x by dt square with a negative sign. Tell me why negative?
Because X is decreasing with time.
Because x is decreasing with time. Get it? Did
Yeah.
you get
Yeah.
it? Okay. Now, what we have to do here, we have to get rid of a force which we don't know anything about, and that being Fs. Fs is a force in abstract, correct, dear?
Yes,
Fk
sir.
we know,
Yes,
maximum we know, but Fs has got ambiguity associated with it. So we try always to get rid of Fs. How can we get rid of Fs? We require one more equation. Why? How many unknowns are there? Please see for yourself. K is
sir.
known to you, R is known to you. So alpha not known, Fs not known, A not known. Correct, yeah?
So alpha will
Yes,
be equal to
sir.
A by R, no, sir.
Yeah. We'll write that down. We'll write that down pertaining to rotation without slippage. Correct, yeah?
Yes, sir.
It's rolling without slipping, so A is equal to R alpha. Got it?
Yes, sir.
Yes, sir.
Now we can get to the equation, which is what we require. Could you please get me an answer to this question quickly, at least this one? You have to get rid of Fs. Will you be able to get rid of Fs now?
Yes, sir.
How? Kxr minus Fsr, right, is equal to I naught. I naught we know, and alpha will be replaced by A by R, right?
Yes, sir.
Yes, sir.
And the other equation we have Fs plus Kx is equal to minus of m d square x by dt square, correct?
Yes,
From
sir.
this one,
Yes,
you
sir.
get Fs is over here, and then take the other A. You will be getting another A here. Please be careful. Okay? If you
Yeah.
replace for
Sir,
Fs, you'll be getting Fs as, what are we getting Fs as? Let me write that down. Kxr, Kxr minus of I naught into A by R, correct?
sir, what I did
And
was,
divided by R. Check it out here. Yes,
sir, in
Krish?
this, so what I did is I took the second equation. I multiplied say, kx plus fs is equal to minus md square x by dt square. I multiplied
Huh.
with r and added both of them. So FSR gets cancelled
Good.
out.
That's the reason I asked. Now you can further, right here.
Yes, sir.
Now you can further and you get acceleration as function of x, right?
Yes, sir. Yeah.
And opposite in nature, correct? This A is same as d square x by dt square, all of you. Is it okay?
Yes, sir.
Yes.
Yes.
We'll have to take it to the right. Find yeah.
Yeah. Yes,
Yeah.
sir.
Take a formula. Getting it?
Yeah.
Yes,
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 sir.
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 Yes.
And from there you'll be able to. So this being another question which we did solve. Now an interesting question which I am coming to. And that being, let us say that there is a pitcher. There's a pitcher filled with water. Is it okay? There's a pitcher
Yes, sir.
which is filled with water. And that pitcher is suspended by a very long thread. There's a pitcher filled with water, and the pitcher is suspended by long thread, very long thread. Pitcher is executing simple harmonic motion. Why? Because it's being nudged. So it is executing simple harmonic. Okay, good enough. Simple harmonic motion with certain time period. T is known to you, omega is known to you. Now water in pitcher freezes. Okay? Just out of blue, it being said that water freezes in no time. And we are not going for the anomalous expansion of water and all. We are assuming volume to remain same. Is it okay?
Yes, sir.
Yes, sir.
Water freezes, but volume remains the same is what we are assuming it to be at. What according to you will be time period now? same as previous, more than previous, less than previous.
So can you repeat the question once? My
Water
connection.
picture being taken. There is a
Yes.
picture with water and it is being taken initially. Let me add first the other part of it and then we'll come to the second part. There is a hole, water drips. What happened to time period? There is a hole at bottom, there is a small orifice at bottom, and water starts leaking off the orifice. Water is leaking off the orifice. So what happened to time period? Tell me.
So first one you told water freezes.
No, fine, I'll come to that later. No issue.
Okay.
Here, the simpler of the two. Let us go
Sir,
for the simpler of the two.
Sir, I guess time period will remain the same because time period does not depend upon mass of the bob.
Okay. Okay. There is radius associated with bob. R. R is the radius associated with bob. Is it okay?
Okay. Yes, sir.
R
Yes,
is
sir.
given. R is given to you. Yes, dear. Someone else will try. Adesh.
Sir, could you just explain the picture part once again?
There is a sphere to you, a hollow shell. You say sphere or shell. So there is a
Yes.
hollow sphere or shell which is filled with water.
Okay.
And there is an orifice. There is an
Yes, sir.
orifice. Water leaks through the orifice. Is it okay?
Yes,
As
sir.
water leaks through the orifice, what happened to time period? Time period of simple harmonic motion execution. Firstly, are you convinced that a bob executes simple harmonic motion? Are you convinced? You have
Yes, sir.
studied this?
Yeah. Yes, sir. Yes.
Yes, sir. Yes, sir.
Ninth standard, but anyway, let me refresh you on it. This mass is M, is being displaced, and over here it is being displaced by an angle theta. And what we do, we write torque about this point. Length of string is given to you. Mg will act. So we take torque. Torque will be written as mg into perpendicular distance. So mg should be multiplied with the perpendicular distance will be how much? See for yourself. This is the point of application. So you extend it. This is the line of action of force. This will be perpendicular distance, correct? Yeah. And perpendicular
Yes.
distance will be acting from here L sine theta, right? Yeah.
Yes,
Check
sir.
it out. Check it out. So perpendicular distance is L sine. Is it okay? L sine theta. Check there.
Yes, sir.
Yes,
Yes,
sir.
sir.
Distance is L sine theta. Mg L sine theta is the torque about this point, and that torque is trying to decrease theta, correct?
Yes, sir.
That is trying to decrease theta. So what do we equate it with? We equate it with I about this point P into minus of d square theta by dt square. Why minus? Why minus? In the previous case, we took minus d square x by dt square. Why so? Because x was decreasing, correct?
Yes,
The
sir.
theta is decreasing.
This is now trying to do decrease theta, therefore minus. What did you?
Yes, sir.
Yes, sir.
And then of this mass about this point, IP will be how much? Is known to all of you, I presume. If not lost on, IP you can calculate easily by ml square. I is moment of inertia, correct? Yeah.
Yes, sir.
Inertia is mass multiplied with the square of perpendicular distance, correct?
Yes, sir. Yes, sir.
Yes,
Multiplied with
sir.
the square of perpendicular distance. So perpendicular distance is over here, L. So what do we get to see? We get to see this equal to minus of d square theta by dt square. Hence, L gone, M gone. We are left with g by L. And if theta is small, sin theta can be replaced by theta, correct?
Yes,
Yes,
sir.
sir.
Okay, so I think you must be getting now on why the teacher used to say that omega square will be equal to g by L.
Yeah. So, yes, sir.
Yes, sir.
Okay, this is omega. Then we get T as 2 pi under root of L by G, correct? Yeah.
Yes,
Yes.
sir.
Yes,
Yes,
sir.
sir.
On this
So,
equation,
but this
are
is
you getting you feel 2 pi under root of L by G.
So, but then this is valid only for a point mass taken as a bob, no sir?
Very good, very good. This is valid and valid only for point mass. If you don't have point mass, if you have sphere, then they need to get you radius of sphere. Got it, yeah? They need to get
Okay.
you a radius of sphere. And when you go over here, then you will apply force not
Yeah.
at less L, but L plus R. Got it, yeah?
Yes, sir. Yeah.
So
Yeah. Yes,
from
sir.
this
Yes, sir.
point, there are 2 points. There are two changes. Not only one, there are two changes. Change number one, L will change to L plus R. Obvious, correct?
Yes, sir. Yeah.
Yes.
And IP will change as well. IP
Yeah.
will change as well. By that,
PML
what
plus
I
R.
mean, IP will be I naught plus MR square. Got it? ML square. IP, now IP means what? You are calculating for this shell, correct? Yeah.
Yes, sir.
This shell,
Yeah.
which formula you using? IP is equal to I naught plus whatever be the distance. In our case, the distance is L plus R, correct?
Yes, sir.
Yes, sir.
So M into L plus R whole square. Getting Krish?
Yes, sir. Yes, sir.
So this is what will be IP then. 2 by 5 MR square plus M into L plus R whole square. In that case, this is to take IP the value. Got it?
Yes, sir.
Yes, sir.
You can
Yes, sir.
calculate. But there slight change. We have to incorporate. We have to factor those changes in. Anyway, back to my question. So with this at the backdrop, if you are wiser on the hindsight, tell me what will happen to time period?
So I guess it will change.
Okay, time period. You can assume that string is of much larger length. So even if you want to go with point mass, I'm good with it. But please don't be dismissive of it because they have given you R. Are you getting it? R you can
Yes,
be
sir.
dismissive of only when you are comparing it with L, not otherwise. Got it?
So one
Yes,
small
sir.
doubt. Sir, in the point mass case, where have you calculated torque about?
Center of mass.
Okay. Yes, sir.
That is the only point because it is point mass. Correct? Yeah.
Yes, sir. Yes, sir.
Tell me in this case. Come on, you have answered my question, Krishna away. You have my answer. My answer is camouflage. Your answer. Come on, tell me.
Yes, sir. I'm just calculating for that too.
Okay. What will happen to time period? I'm not asking you to calculate. I'm asking you to go ahead and let me know. Firstly, will it change or not? So Vedant is suggestive of it will change. Okay, so it will
Yes, sir.
change. Why should it change?
So because L plus R, sir, the length of string, the effective length will change.
Okay, effective length of spring will change because we calculate length from point of suspension to center of mass, correct?
Yes, sir. Yeah. In that case, center of
Length
mass.
from point of suspension to center of mass, correct? Yeah.
Yes,
Yes,
sir.
sir.
As the level of water recedes, as the
Yes.
level of water recedes, center of
Center of mass.
mass of water will keep on descending, correct?
Yes, sir.
Yeah.
Previously, center of mass of water was coinciding with center of mass of shell, correct? Yeah.
Yes,
Yeah.
sir.
When
Yes, sir.
shell is completely filled, that center of mass of water is superimposed at center of mass of shell, correct? Yeah.
The time
They are
period will increase.
superimposed. The 2 points are superimposed. Semi Asano, where is center of mass of shell? Here. Where is center of mass of water? Here. When it is completely filled with water, correct?
Yes,
Yeah.
Yes, sir.
Now, as water is to move down the orifice, then let's say now it is half filled. Where lies center of mass of water? Here.
yes,
Remnant water? Correct? Yeah. Center of
yes, sir.
mass of remnant water. Where will it lie? Here.
Yes, sir.
And
Yeah.
where will lie center of mass of shell? It will remain
At the
this itself,
center.
correct?
Yes, sir.
Yes.
So what is happening to effective center of mass? it is shifting downwards. Agreed, yeah?
Yes, sir.
Yeah, yes, sir.
And center of mass is shifting downwards. Effective length is increasing. So time period will increase. Got it?
Yes,
Yeah,
sir.
yes, sir.
Yes, sir.
Okay, what when water is drained completely out of the sphere?
So
What
time period
when
is max.
So
water is, yeah. Then
So
dear,
time period is maximum.
yeah,
yeah,
maximum.
Yeah.
no, 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 no.
Constant.
Time period will get restored. The time
Okay, yeah.
period will get restored. It will reclaim its initial value. Correct, yeah?
Yes, sir.
Yes, sir. Yeah.
Water, it is denuded of water. If it is devoid of water, where will lie center of mass of shell? Back to
At
this
center of mass.
position. Back to this position. Correct, yeah?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Shell was always over there. Water was the change, but there is no water now. So where will you say is the center of mass of system? Here only. Correct?
Yes, sir.
Yes, sir.
In that case, what will happen? You will say first the time period is to increase as water is descending, and then time period will be back to its organic value. Correct?
Yeah,
Yes.
yes, sir.
Okay. So that is how time period will change. Anyway, this was a digress from my question. My question being on, there was water and it freezes all of a sudden. Willingly it freezes. How? I'm not going into that detailing. It freezes. From liquid, it solidifies. So if it is solidifying, then what will you say on time period? Will it
Yes.
change? Yes. Increase, decrease, and how we will go about solving that question. Will it change? Will it increase? Will it decrease? How we will go about solving that question? Is it okay? Is my
Yeah.
question clear to all of you?
Yes, sir.
Articulation?
Yes, sir.
Okay. So you will think
Yes.
about it. What happened to this case? As it is, this again is a question from IRDO. Think about what happened, and if it is to change, what should be the time period? And it's a very important question because this is to unfold an aspect of rotation to you. Very important aspect of rotation to you. So please try solve this question. Okay, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
If you want me to solve it, I'm good with it, no issue.
So we'll
You give
try.
us one, give one class
So,
time. If you don't get it, you solve next class.
Okay, okay, fine. So you'll try for this question, and I think you should get it. If not, we'll be solving it. It's a very good question. Okay, next. Few more questions on simple harmonic motion, shall we? Or you want to ask something? Some doubt you have. Any doubt if you have, ask. Else we'll take few more questions on simple harmonic motion.
Sir, I don't have doubts, sir.
It's the same.
Yeah, sir, I have a doubt. Not in this part in electrostatics when we have when discussing with everyone. I'll ask.
Okay, fine. Then I ask you a question right now. A mass of a mass of 5 kg is made to oscillate with the help of a spring constant K. With the help of a spring constant K. This spring is now cut. This spring is now cut in two equal halves. Equal parts maybe. Half is of course equal. In two equal parts. And placed left and right the mass as shown. And placed left and right the mass as shown. Find time period of simple harmonic motion execution. Find time period of simple harmonic motion execution.
So
Let
this
me
is a
make
question from
my
Erodov.
Yes, dear.
So this is a question from Erodov, no?
Yeah, you can say. There they
Yeah,
have
I
cut in
saw
the
the
ratio
question.
1:3. 1:3 there.
I saw this type of diagram in the book.
Yeah. There they have cut 1:3. I made it slightly easier by cutting it into two equal halves. And then we have to find what will be time period. If the spring is in 1, if the spring is present in 1, then K value is K. Is it okay?
Sir.
If the spring is present in one piece, then value of K is K. Are you getting it?
If it's 2,
Yeah.
2k each.
Yes, correct. Very good. But you did cut into two equal halves, so it cannot remain K. What will it be? Is 2K here and 2K here. And how did we get to know about it here?
KL is constant.
Yes, KL is constant. Very good. So from there, you got to know that there are two springs now, and then nothing much is left. Now you can shift to the right. Correct? Yeah. By X.
Yeah.
Same yes or no?
Yes, sir.
Yeah. Yes.
Left will pull it with 2kx. The right will push it with 2kx. Correct?
Yes, sir.
Yes, sir.
And you will write minus of 4kx is equal to m into d square x by dt square. That's the solution. Correct?
Yes, sir.
Got it here? Same yes or no? Adesh? Adesh?
Yes, sir.
2kx,
Yes, sir.
2kx.
Yes, sir.
2kx square from there, we get to know that omega square will be 4k by m. Correct?
Yes, sir.
Yes, sir.
Now let me come to the Eurodome
Yeah.
question. 1:3. Spring is cut into 1:3. Tell me. Spring is cut into ratio 1:3. Tell me how will you go about it? Spring is cut in the ratio 1:3. Anyone take the lead? This
So
time
one
it is
second.
cut in the ratio 1:3.
So one will be 4k. Yeah, one will be 4k and other one will be 1 second, sir. 4k by 3.
Okay. I take that. Good, Krish. Of course, you are talking of 1x and 3x as the total length, which is 4x, correct? Yeah.
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 Yes,
Yes,
sir.
sir.
4x total length. So 4x relates to k, correct? Yeah.
Yes, sir.
And let us say now k got changed. Previously, what would have been the product? K into 4x. Now you
Yes,
don't
sir.
know what is k prime, but you know the other length is 3x, correct?
Yes, sir.
I told you the other day that kx product remains constant, correct? Yeah.
Yes, sir. Yeah.
So
Yeah.
k
Yes.
4x for the organic and k prime the change k into 3x. So k prime, as did say Krish, will be 4k by 3 for one case, right? And the other one,
Yes,
k
sir.
into 4x is equal to k double prime into x. X, right?
Yes, sir. Yes, sir.
K
Yeah.
double prime will be how much? Will be equal to 4k, correct? This
Yeah.
was the only catch in the question. Once you know what are the value of k prime and k double prime, you know what will you get over here, right? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. Now the last question that I'll be taking for this day, write down. There are two springs. There are two springs of spring constant. There are two springs of spring constant K1 and K of spring constant K1 and K2, with K1 being attached to mass, with K1 being attached to mass, and K2 arranged as shown, and K2 arranged as shown, touching mass at this position, touching mass at this position.
Is it the same diagram?
Yeah, it is the same diagram, but with a tweak there, small change.
Okay,
In the
okay.
previous case, you had both the spring nailed to mass. Got it? In
Yes,
the
sir.
previous case, you had both the springs nailed to mass. They were nailed into the mass. Got it? Yeah.
Yeah.
Whereas in this case, one spring is the same, the other has got an open end. Getting it?
That means the mass can get detached from it.
Come again, dear. Mass can? Yeah,
Get
exactly. Mass can get detached. It is generally shown by a plate which they say is weightless. Is it okay? They show it this way. Okay?
Yes, sir. Yes.
So this is the scenario here. Or they say that it is a cord, elastic cord. Got it, dear?
Yes, sir. Yes, sir.
So anyway, this is the scenario out here. K1, K2 known, M known. Find time period. Find time period. Find time period of this simple harmonic motion or whatever, periodic motion. Find time period of this motion. Find time period of this motion. Think about it, it's not difficult. Just the change of perspective. Not much difficult. How shall we go about it? Anyone? Get me some proof at least.
So can we take two cases where in one case the mass doesn't get detached, and in one case the mass will get detached?
Okay, fine. I'll lay credence to that. So, are you suggestive of Krish when it moves to left? Are you
Yeah.
suggestive
When it
of
moves to left,
if the mass
yes,
is
sir.
moving to left, then there
When
is
it
only
moves to
one
left,
spring to act on mass?
yes, sir. Yeah, that's what I meant.
Yes, exactly the case. If the mass is moving to left, then there is only one spring which is effectively acting, and that is of spring constant K1, because this spring will detach. And on contrary, if mass is moved to right, then both the springs are to act. Correct? Yeah.
Yes, sir.
Yes, sir.
Mass moves to right, then K1 will act and also will act K2. If it moves to left, then K2 cannot stretch as it is not nailed. So only will act K1. Got it, yeah? Got
Yes.
it, Adik?
Yes, sir.
Pratyush? Pratyush?
Yes, sir.
Yeah, Pratyush?
Hello. Yes, sir.
Okay. So left if I'm asking you now to tell me what will happen if the mass moves to left. You will say K1 will act and will act K2, correct?
Yes, sir.
Now I will
Yeah.
ask you, the two springs over here are in which combination? Parallel combination or series combination? Though is not
It is.
required much because you are known to. I'll come to that later. Let me keep that question for later. You know that K1x will be to the left, right? Yeah. And K2x will also be to the
Yes,
left.
sir.
Agree? So K1x,
Yeah.
Yes,
K2x
sir.
to the left. is equal to m into d square x by dt square. Got it?
Yes, sir.
Yeah, yes, sir.
So we get over here time period as 2 pi by omega, where how much is omega? Where how much is omega? Omega is equal to k1 plus k2 by m whole under the root. Agreed?
Yes, sir.
Yes, sir.
Check all of you. Is it fine?
Yes, sir.
Yes, sir.
So this is omega in this case, and time period will be 2 pi by omega is what we are saying. But are we getting this as time period? When it goes to right and return, when it goes to right and returns, then it is completing half of the total motion. Agreed?
Yes, sir.
Yeah,
Yes,
yes, sir.
sir.
Yes.
Right and returns, then it is completing half of the total motion. Getting it or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
For total
Then,
motion, it will have to go to left and then come reclaiming this position. Correct? Yeah.
yeah,
Yes,
yes, sir.
sir.
So
Yeah, yes,
that
sir.
means you have to take a combination. We have to take
Yes.
combination of both
We
left and right in
could
one
have
case.
taken Krish 2 pi by, we could have taken Krish 2 pi by omega. I write it
And
this way for you. Pi by omega plus pi by omega. Are you getting it?
yes, I got it, sir.
Pi by omega for front and back, and pi by omega for back and forth. Is it okay?
Yes, sir. Yes, sir.
And that gets us 2 pi by omega. That is how we write time period. But here situation is slightly disturbed, as when it goes to right, then you relate with omega 1. When it goes to left, then you relate with omega 2. Because to the right, this is omega 1. When K1, K2 both are operational, correct?
Yes, sir.
Correct. And to the
Yes, sir.
left, to the
Only
left,
K1.
K1 is operational, which is K1. So it will be K1 by m under the root. Got it?
Yes, sir.
Yes, sir.
Yeah.
So you know what to do. Pi by omega 1 plus pi by omega 2. This will be the total time period. Got it, yeah, all of you?
Yes, sir. Yes,
Yes,
sir.
sir.
Oh, yes, sir.
This is how we have to calculate for the situations in which you have elastic cord given. Elastic cord also will apply force only when extended, correct?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so sometime we'll get you elastic cord. Okay, now I was on spring being parallel or series. How do we get to know spring is in which combination? Is the spring in parallel combination or is the spring in series combination? How do we get to know? If I have taken, good. If I have not taken, please let me know. Did I
No, sir.
take combination springs?
No, sir. You're not taking combination of spring.
So let us take combination of spring quickly. This is one spring of a spring constant K1, and this spring is conjoined with another one of a spring constant K2. This is to me wall, and this to me the mouse. We apply some force to make the mass move. So I don't know by what the first spring will expand. I write it x1. I don't know by what the second will expand. I write it x2. So total expansion for us is x1 plus x2. Got it, yeah?
Yes, sir.
Yes, sir.
Now FBD for this mass. On this mass, one force F acts to the right and the other force. Now this is to be very careful about. K2x2 only. Other force, which spring is in contact with it? The spring mass K2, correct?
Sir.
And that
Yes, sir.
spring is extending by what amount? X2. So what force it can apply? It can apply force K2x2. Got it?
Sir.
Yes, sir.
So F to the right and K2x2 to the left. That is what we are getting. Find here. So what is F equal
Yes, sir.
to if it is moving very slowly? If it is moving very slowly, then F is equal to K2x2. If it is moving very slowly, then F is equal to K2x2, right?
Yes, sir.
Yes, sir.
Think about this point, the middle point. F force from this side is K1x1 and force from this side is K2x2, correct?
Yeah. Yes, sir.
And
Yes, sir.
it cannot In the balanced state, it cannot move to left or right. So what do we get over here common is K1 X1 or K2 X2. By common, what I mean tension. This is called tension. Tension through and through will remain the same. In this combination, what is same through the spring? Through the springs is tension. Got it, yeah?
Yes,
Yes,
sir.
What
sir.
will remain
Yes.
same is tension. Everywhere tension will read the same because we are talking of one strand. So tension will remain same. I'm writing for midpoint as I stand beneficiary of this point. K1 X1 is equal to K2 X2, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now I want this cascade to be replaced by what? I want this cascade that I got to be replaced by one spring of K equivalent value. Is it okay?
Yeah.
Yes, sir.
So
Yes,
F
sir.
remains same. Of course, external circuit should not get to know what changes you are bringing about. So F is same. Displacement should also remain same, correct?
Yes, sir.
Equivalent means what, dear?
Yeah.
Equivalent means you are keeping it from the external part of circuit, correct, yeah? You are
Yes,
keeping
sir.
your
Yes, sir.
changes from the external part of circuit. So you cannot change X1, you cannot change X2, you cannot change F, correct?
Yes, sir.
Internally, K1, K2 being replaced by K equivalent, and we get F is equal to K equivalent into X1 plus X2. Agreed?
Yes, sir.
Yes, sir.
Good.
Yes, sir. Yeah.
Yes, sir.
Now you know what to do. F is how much to us? K2 X2. Agreed?
Yes, sir.
Is
Yeah.
equal to K equivalent, right? Into. Get me a substitute for X1. K2 X2 by K1.
Yes,
Yes,
sir.
sir.
Yeah.
X1 can be replaced by X1 can be replaced by K2 X2 by K1. Say yes or no?
Sir.
Right?
Yeah.
And X as it is, correct?
Yes, sir.
We get K equivalent from here. Check.
1 by K
Check.
equivalent is equal to 1 by K1 plus 1 by K2.
And this is what you have. 1 by K equivalent is equal to 1 by K1 plus 1 by K2. Write it down. And this is
So,
what combination to you? This is series combination. Got it? Because in
small
series
question.
combination remains same. Why I'm saying this to be series combination? In series combination, what remains same is tension. Got it? In series combination, what remains same? Tell me. Is tension. Got it?
Tension.
Yeah.
Yes, sir.
Okay. So what
Sir.
you get from here? Write it down, please. 1 by K equivalent is equal to 1 by K1 plus 1 by K2.
So, one small question. Sir, if
Yes, yeah.
we can take x total is equal to x1 plus x2. Sir, and
Yes.
kx is equal to constant. So can we take constant by k equivalent is equal to constant by k1 plus constant by k2?
Yeah, but then you have to get rid of X2, Nakrish. That you can write. But how will you get
Okay.
rid of them? Because you're having both X1, X2. You need to get rid of them, correct?
Okay. Yes, sir.
That's the reason I change it to X2 through and through so that I can get rid of X2.
Okay. Yes, sir.
Okay, so 1 by K equivalent is equal to 1 by K1 plus 1 by K2. Got it? These questions are very frequently asked in small time examination, I'll say. What they will do, they will get you one spring connected with the other spring and then they will ask what will be time period. So if they are in series combination, you know what to replace two springs by, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And the other one is all the more simpler, which is parallel combination. Right on. In parallel combination, deformation remains the same. Please mind my words, class. I didn't say extension. I didn't say compression. I said deformation remains the same. So if this is spring is of spring constant K1, this is spring is of spring constant K2, and you are pulling out block. what force you require to pull it with? Force will be K1x plus K2x. Agreed?
Yes, sir.
Because x should remain same. You're not changing the orientation of mass. Are you getting it? You're moving
Yeah.
it this way, rotationally. So if this extends by x, this will also extend by x, correct?
Yes,
If
yes.
this deforms by x, this will also deform by x, correct?
Yeah.
Yes, sir.
Now what will you do? You will remove it by one spring. So remove it by one spring, mass m, force should remain same, and also displacement should remain same. Agreed or not?
Yes, sir.
You are keeping alien from external elements. So x is the displacement here, x should be displacement here. What do we write? Force now equal to K equivalent into x. Agreed?
Yes, sir.
What will be K equivalent?
K1 plus K2.
K1
Yeah.
plus K2. So in this case, K equivalent is K1 plus K2. Got it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Combination is this, a combination in which deformation remains same, and such combination is called parallel combination. Is it okay?
Yes.
Yes, sir.
Yes, sir.
This is parallel combination. Got it?
Yes, sir.
Now the question which I got you. Tell me in this question, the two springs were in what combination?
So series.
What combination they were in? This is K1, this is K2. What
Sir,
combination they were in? Quickly?
series.
No, no parallel. Parallel.
Parallel, yeah, parallel combination. Deformation remains same. This compressor
Yes, sir.
by
Yeah.
same amount, but this elongates. So this was parallel
Yes,
combination. Yeah.
Questions
yes,
are
sir.
different.
Yes, sir.
Okay, questions are to come again. In the next class, we will be viewing few questions on this combination series. India, thank you for the day.
Yes, sir. Thank
Thank
you,
you,
sir.
sir.
Can you send maths questions for AITS?
All right, right. Yeah. Sure, I'll send you for sure today. Okay.
Yes,
Sir, I
sir.
have a question, sir. So for physics,
Yeah.
do I need to solve NCRT?
NCERT, if you're solving, you're doing no bad in a way. Why? Because it will help you. So if you do get time, you should go through it. Questions
So, but
are
is it
there.
important for
You should never be an arrest to question flow, dear. It's all about time. If you're able to manage, you should solve. Why will I barricade you from question solve?
Yes, sir. Okay.
NCERT, second part is good. First part is okay to the board level cap. The second part is good enough to give a try to.
Yes, sir. So because in Alan, sir, they're continuously saying solve only R module, don't solve even
They
extra
will do
books
about
like
it.
you know.
That you know why they are doing. I need not
Yes,
educate
yes,
you
sir.
on that.
I
Yeah.
know, I know. Yeah.
There are motives. You can very well impute motive to all those statements.
Yes,
Solve
sir.
NCRT as well because questions are in board to be asked of NCRT. In your school examination also, they are to pay heed to NCRT only. Correct?
Yes, sir. Yes, sir. Okay. Thank you,
Solve
sir.
it. If you are in crunch of time, then I will ask you to go for SC Verma and Erudov directly. If you are not, which you are not, of course, now. So you should try.
Yes, sir.
Okay.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.